Material Requirements Planning (MRP) depends on numerous planning factors that influence the accuracy and effectiveness of material plans. Examples include customer demand patterns, forecast accuracy, supplier lead times, lot sizing rules, safety stock policies, production schedules, inventory accuracy, purchasing constraints, capacity limitations, and engineering changes. Because MRP calculations rely on these variables, planners must continuously monitor and maintain planning parameters to ensure valid results. Changes in any planning factor can significantly affect material availability, inventory investment, and customer service performance. Effective material planning requires a thorough understanding of how these factors interact and influence requirements throughout the supply chain. Accurate planning data supports reliable replenishment decisions and efficient resource utilization. An effective item numbering system is essential for organizing, identifying, and managing materials throughout the enterprise. Item numbers provide a unique identifier for every purchase part, raw material, component, subassembly, and finished product. Consistent item identification improves inventory accuracy, purchasing efficiency, engineering control, and information management. Item numbering systems generally fall into two categories: significant and non-significant systems. Significant numbering systems embed descriptive information, such as product type, size, material, or category, within the item number itself. Non-significant systems assign sequential or random identifiers without embedded meaning. While significant systems may simplify recognition, non-significant systems offer greater flexibility and reduce complexity when products, technologies, and classifications change over time. MRP generates several important outputs that support planning and execution activities. Planned order releases indicate when orders should be initiated to ensure material availability, while planned order receipts specify when materials should arrive. Action messages alert planners to conditions requiring attention, such as rescheduling, expediting, delaying, canceling, or releasing orders. Additional outputs may include exception reports, inventory projections, pegging information, and capacity-related alerts. To maintain accurate planning information, organizations utilize either regeneration or net change processing approaches. Regeneration recalculates the entire MRP database periodically, whereas net change processing updates only affected records following transactions or planning changes. Both approaches support ongoing maintenance of material plans and system integrity. The MRP time-phased record, often called the MRP grid, serves as the primary tool for displaying and calculating material requirements over time. The grid typically includes gross requirements, scheduled receipts, projected available balances, PABs, net requirements, planned order receipts, planned order releases, and firm planned orders, FPOs. Gross requirements represent total demand, while scheduled receipts reflect existing open orders. Projected available balance shows expected inventory after demand is satisfied. Net requirements identify shortages that must be replenished, and planned orders determine the timing of future supply. Firm planned orders provide additional schedule stability by preventing automatic system changes. Together, these elements provide visibility into future material availability and planning requirements. MRP planning logic is based on a structured sequence of calculations that transform production schedules into detailed material requirements. The process begins with Bill of Material (BOM) explosions, which translate parent item demand into component requirements throughout the product structure. Low-level coding ensures that each item is planned only after all higher-level requirements have been calculated. Lead time offsetting determines when materials must be ordered or produced to support scheduled completion dates. Gross-to-net calculations compare total requirements against available inventory and scheduled receipts to determine net replenishment needs. These planning principles enable MRP systems to coordinate complex material flows efficiently while ensuring that components become available when needed for production activities. Closed-loop MRP extends traditional material planning by integrating master scheduling, capacity planning, production control, final assembly scheduling, and configuration management into a unified planning system. Feedback mechanisms provide information regarding actual performance, inventory status, order progress, and capacity utilization. Planners use action messages, exception reports, and bottom-up planning techniques to resolve imbalances between supply and demand. Effective closed-loop MRP continuously monitors material availability, timing, priorities, and execution performance. Common performance metrics include inventory accuracy, schedule adherence, planning stability, stock-out frequency, order completion rates, supplier performance, inventory turns, and customer service levels. These measurements help organizations evaluate MRP effectiveness, identify improvement opportunities, and ensure alignment between planning activities and operational execution.